Hey, I hope you have your notes ready because this is going to be a whole lot of examples talking about how to multiply and divide monomials with exponents. So notice here that I have the same base. We're going to start with multiplying powers with the same base. When you have that, the rule is keep the base and then add the exponents. But I want you to see why. The reason why is because 6 squared is 6 times 6. Agreed? Times 6 to the third. Do you see where the base remains 6 and there are 5 of them? So that is 6 to the 5th power. On this one, I'm going to scoot you over a little bit. On this one, the same base, that's x times x times x times 1, 2, 3, 4, 5, 6. Everything is being multiplied. So that's really just x to the 9th. Hopefully that's making sense to you. Let's move to what if they give you a variable? And now look at this. Notice this is negative n to the third. They're both negative n, so just keep that quantity as negative n. And this is going to be to the 5th power. Now you know enough about negative numbers by now that it's going to be a negative product, because if you have an odd number of negatives values being multiplied together, then of course your product will be odd. Negative. Okay, here, let's look. Hope you've got those notes done. If not, pause and catch up with that. Now let's look at these. Multiplying powers with a coefficient. See, notice these have a coefficient. And then I have some with different bases. So let's see how that works. If you were to expand these, sorry, I erased the P. If you were to expand these, it would look like this. 5 times 1, 2, 3, 4. And then 4 times 1, 2, 3 P's. So do you see where you're just going to take the coefficients and go ahead and multiply them together? 5 times 4 is 20. And how many P's will be multiplied repeatedly? 1, 2, 3, 4, 5, 6, 7. Because 4 and 3 is 7. There you go. I'm going to do another one just like that before we get to the next. Let's say you have 3 V to the 5th times 7 V to the 4th. You're going to take the coefficient times the coefficient. In this case, it's 3 times 7, which is 21. Then you're going to multiply your powers. V to the 5th times V to the 4th is V to the 9th. And if I had expanded that, that probably would be more clear. But I don't think, most people won't expand them when they get this big in the numbers, but we'll see. Okay, this one is the same thing. When you have 7k squared and n to the third, that's the same thing as 1 n to the third, correct? So you're really doing 7 times 1, which is 7. Then you have k squared, n to the third. And of course, you're going to go in alphabetical order with your variables. K comes before n. Now this one, I tried to see how complicated I could make it. You are going to multiply your coefficients together. You have negative 6 times positive 4 times negative 2. Well, I'm going to take the two smaller and go ahead and multiply those. That'd be negative 8, right, times negative 6, which is going to be a positive 48. So you have two negatives, so it's going to be a positive. And now let me multiply another way to make sure I'm right. 6 times 4 is 24, times 2 is 48. Okay, so my coefficient is correct. And I have an n cubed p squared x to the third. And I am done. Okay? Let me do one more because I noticed that I didn't do any singles. What if I had 3x times 2x squared times 5z, I hate using z, but z. Okay, here I'm going to take my coefficients. 5 times 2 is 10. 10 times 3 is 30. This is x to the first. So that is going to be x to the third. So if there's no superscript, as they call it, or exponent with a variable, you assume it's a 1. And this 1 plus those 2 would give you a 3. and then z. And I'm not going to put the 1 over z, that's it's redundant. Okay, so there we have it. Now let's get into dividing. Now dividing, I really like this. If I have 6 to the third over 6 to the fourth, there's 3 of them on the top, there's 4 6s on the bottom, correct? So because they're multiplying and not added, these cancel one another, because 6 over 6 is 1. 1, 1. Your answer is not 6, by the way. You have to preserve the integrity of that numerator. These really simplify to 1. Your answer is 1/6. So I know we haven't gotten there, but you know how you add the powers when you are multiplying? You actually subtract when you are dividing. This would actually be 3 minus 4 is 6 to the negative 1. But 6 to the negative 1 is 1/6. Okay, let's look at this one. You have 75 times 75 over 75 times 75 times 75 times 75. And of course, these two will cancel each other, and you have 1 over 75 squared. Looking at this one, you have 10 times k times k times k over 5 times k times k. 10 and 5 are going to simplify to 2. And these are going to cancel, and you have 2k. Now, I know you'll be tempted to say 2k over 1, but that is not convention. Convention says if you have a numerator and no denominator, just leave it as a whole number. Now let's look at this one. 12, and there's 3 n's, it's 24, and there's 4 n's. Let's see how this looks. Okay, these are going to cancel one another. The 12 and the 24 both divide by 12. This will be a 1, this will be a 2. So my answer is 1 over 2n. Some books will actually call that 1/2, oops, let me do it. 1/2 n. They'll put the n as kind of like to the side as a variable. These two are the same numbers. 1 over 2n and 1/2 n are the same value. Now, whatever you do, don't put the n on the top. But okay, let's look at this. I'm immediately going to kill those zeros. 6 over 8, I'm going to do it without expressing it. 6 over 8 is 3/4, right? X cubed over nothing here is x cubed. Now you can say 3/4 and leave the x cubed in the numerator, or you can do 3/4 x cubed. It matters not. I like assigning the variable to the appropriate place, be it the numerator or the denominator, because it makes, when you're multiplying and dividing these when they're in equations, to me it makes it easier. Okay, one more scenario. What if you had negative, let's make it a variable, x to the 8th over negative x to the 5th. Some people will be tempted to get rid of those negatives, but you can't. This is negative x 8 times. So 8 minus 5 is going to be 3, but you're going to keep it negative x, okay? Because that is a quantity that is being taken to a power, so leave it in the parentheses. Don't cancel that, okay? All right, you take care.